Okay, this time we're going to try another acid-base one. This is a little bit of an older one, but it still seems pretty accurate with a few minor exceptions here. So let's again try this on your own. Pause it here, take a look at the question, and then we will continue it in a second. Okay, so the first part here is that we have a weak acid, hypochlorous acid. We know it's a weak acid because they give us a Ka, and they give us the equation. And we're supposed to find the H plus concentration. So a couple things we want to do with this. First of all, we can think about it in terms of we need an expression for our Ka. So I think now the more recent questions would absolutely ask you for this, but we'll have it here. So we have H plus OCl minus over HOCl. Okay, and at this point, I'm assuming you can do ice if we're talking about just the concentration here. So remember, this would be 14 minus x, but the x is negligible. Each of these will be plus x, so it'll come out to x squared over our 0.14. And we were given our Ka, which is 3.2 times 10 to the negative 8. And so we do that and solve for x, which is going to be equal to our H plus concentration. We find that that concentration there is going to be 6.7 times 10 to the negative 5th molar. Okay, so that gives us our H plus. They're not asking for pH or anything, they're just asking for concentration of H plus ion there. Okay, and so the next part is they're asking us to write a balanced net ionic equation for the reaction that occurs when this compound is dissolved in water. So we already have two things, but say net ionic equation, and the reason they're saying that is because the sodium is not going to be part of it. Sodium is just going to be a delivery device for this OCl minus ion into the solution, so really all we have is OCl minus aqueous, reacting that with water. And so in this case, so this is our conjugate base of our weak acid that we started with. In this case, water is actually going to act as the acid, and then so that's going to give us our hypochlorous acid again, so HOCl, and we're going to end up with OH minus. And so we can see producing OH minus, this is why this is our conjugate base. It's a base, it's going to produce something with a basic pH because of this OH minus that's produced when it reacts with water. And so the actual value then, so if we have our Ka, and we need to solve for our Kb, we can take advantage of the expression Ka times Kb is equal to Kw, where Kw is always going to be equal to 1 times 10 to the negative 14th for our purposes. That's the only value they give us. Okay, and so if we do that, we can solve for our Kb, which is going to be Kw 1 times 10 to the negative 14th, divided by our Ka, which we were given as the 3.2 times 10 to the negative 8. And so our Kb then is equal to 3.1 times 10 to the negative 7th.